Hello everyone, welcome to Overflow. In this video, we'll discuss another LeetCode problem. That is a make the string great. This is an easy type problem, and we'll understand how you can do this easily. I mean, it's easy as well. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Overflow for regular LeetCode videos like this. The question says we are giving a string S which contains lower and uppercase English letters. So there's a string S given to us. Fine. Only lowercase and uppercase letters are there. So a good string uh, is a string which doesn't have two adjacent characters. The S1, like S of I and S of I plus one, where like we need to see like two things. Okay, so we need to see like there's an S of I that is a character in the string, and the next character that is a exactly consecutive character, the next character. So there should not be two adjacent character such that uh, these two characters like S1 is a lowercase and S of I plus one is uppercase. Like the same character which over here is in a lowercase and over here is in uppercase, or the reverse over here in uppercase or over here in a lowercase. So we shouldn't find this kind of adjacent characters. Simply is that we need to see that there should be consecutive characters which are uppercase and lowercase. Okay, so if anything of that exists, we should do like what we should do, we should remove them, right? There should not be which does not have this adjacent character, right? So like to make a string good, we can choose two adjacent character which make the string bad and remove them. So basically we need to choose two of them and remove them. Then we can keep doing this until the string becomes good. So we should keep doing this. Now we should return the string after making it good. We should basically return the string after making it good. The answer is guaranteed to be unique under given constraint. So they guarantee that the answer will be unique. Okay, so that's confirmed. Now, how will you do that? Let's say the basic question is over here. What will happen? It's like CLEET. Okay, that's like you can see small e and capital E. That's you find it over here. Then two times e is being repeated. So this two times e is being repeated. This is not our concern. So first we encounter a small e, then we encounter caps e, right? So once we encounter a combination where first we get a smaller and a caps, or the reverse one. First we got a caps or a small followed by a small. Then we should remove both of them, right? So when we remove both of them, the rest to e remains, right? And there you see that we found answer. Okay, so this is how we can do it. Now, there's a problem with this. The problem being C over here. Now, A, then BB, then A, right? If we remove this BB, that's was the condition for us for a string to add, right? So if we remove this BB, we'll be coming up to something like AA. There will be once removed, then A will be consecutive, right? So we need to remove A as well. Then we will find CC. Then we'll remove CC as well, right? So the thing is like we should look back as well. Once our string is removed, we need to look back from that position that whether these two characters are also making the string bad or not after the removal. Okay, so this is our criteria, or this is a condition that we need to follow. Now, whenever you find a question like this, I would suggest, see, there can be multiple ways to solve this question. Definitely, it's an easy type problem, and there can be multiple ways to solve this. But I would suggest think of something in the lines of stack. Okay, that doesn't mean exactly using a stack data structure, but obviously a concept of stack would be much useful. Why? Say over this concept, okay, like taking this first we found small a, we put it into a stack, fine. Then we found small b, we found like the stack top isn't equal to or greater than, like the stack top isn't a capital letter of the small letter of the current element. Current element is b, so we just pushed it into a stack, right? We found b. Next we found caps b, so we found caps b, right? Capital b, so we found the capital B is actually stack top, that is the small b, uh, and the capital B. So we found this is the capital letter of the stack top, right? So what do we do? We remove what stack top. Okay, so stack top is removed, and our current capital B also removed. That is, it's not added in our stack. Then we found capital A. Okay, now what's our stack top? Stack top is over here. We found capital A. So this capital A will be like, we find that this is the capital of this current stack top, right? So we remove our A from this stack. Then we found C, right? So we moved like pushed C, small c into our stack. Okay, so stack top is over here right now. Fine. These two elements are not there, so that's the like the 0th element in the stack of the first element in the stack being pushed into it. Now that's the stack top. Then we find capital C. So once we encounter capital C, we find that this is actually the capital of the stack top. So we remove the stack top and also doesn't push this into the stacks. Okay. So at the end, whatever is left in the stack, fine, we simply pop this in a reverse order. Like obviously, whatever in the stack is the end characters one by one, like the last characters. Okay, we need to pop it. So over here, we didn't find anything. So we just left with the empty string. Fine, that's the empty string being left. But over here, if you see, just if I just try to take the example till the late, next you can understand. So first we find a L, that's the stack up. Then we find small e. Okay, then we find capital E. Capital E we find that's the caps of the stack top. Stack top is over here. Fine. So we remove small e. Then we find again small e we find. Why? Because the first small e and the first capital E are removed. Then again small e. Then again small e because they are not the capital of each other. Okay. Then we find T. Okay. And then similarly CODE will be there. And now when we are once we are removed or done with it, what we'll do, we need to write it. So we'll keep popping from the stack. The popping from the stack, we have T at the last. So T, then we have E before it, then we have E before it, then we have L before it. So that's how it is going formed. Okay, so we need to keep in mind that when we're popping on the stack, we need to go from like end to the first in our string. That's a pretty much idea. But if you're using the stack data structure, like the stack from our collections framework, there you may see a rise in a bit rise in the whole time. Like it is the first. It you cannot determine like say it is not the fast. It is fast, but you can say a slight lag in the uh, entire data, like entire time runtime. Okay, more or less the complexity remains same. So how what you can use? You can create your own stack in the sense that create a like in simple sense create a character array and take that as a stack. Okay, one by one, keep adding your characters into this array, and then if there's an we find that it's smaller and the capital as well, so we move a pointer one step back. Let me quickly show you what I mean with this. Okay, let me quickly clear all these drawings and show you what that means. So over here you see like we took a character array and obviously left it as a stack. We just keep in mind that we are doing a stack operations. Okay, let's see what we are doing. We just take it a new character array of length, the current string length. Fine. Now the stop at -1, that is it's before the any character. Okay, it's currently pointing at none of the characters now. But we move from character to character, that is from 0 to the s dot length, and we find like if top is greater than equal to 0, that means there at least one character being pushed into our character array, right? If top is greater than equal to 0, initially is -1, so at least one character that will be equal to 0, more than one character that is greater than 0, right? Then if top is greater than equal to 0, let's come to this point later because currently our stack is empty. So what do we do? We just incremented our top, that is a pre-increment, and once we incremented our top, we added to the stack element that's current character in the string, like the string given us character type. Fine. Else, like once the first character is inserted, we keep checking that the top is greater than equal to 0. Yes, right. And then what we do? We do the math dot absolute. Absolute of what? S dot character type being what's the current element, like the current character value we have. Okay, is this character minus stack top. What is the stack top? The same thing we're doing, the top of the stack. And if the absolute value is 32, why 32? If we look carefully, the difference between small a and capital A is 32. Similarly, the difference between small z and capital Z is 32. So all the characters, all the 26 characters in the smaller small case and the uppercase have a inter difference is 32, right? So we just check if the difference is 32, we just make our top minus minus. We just move a pointer one step back, making sure that there's nothing, the previous characters are also removed and also current character is removed. Okay. Else we simply keep on adding the elements to our stack. Okay, this stack, as I say, is a character array. Then we simply make another character array. This character array has a length of top plus one. Whatever our current top is, we have a one character more. So that we can incorporate our answer in it, fine. And then while this top not equal to minus one, like while we doesn't reach a minus one, we just simply keep on shift, like moving one by one character to from this stack to our answer array, right? And just keep reducing our top. As I say, we should go in a reverse manner. Okay, we should not go in the forward manner as I was showing. So we just moving from the reverse manner, like one by one. Whoever is the top, we are shifting in the last and then moving towards the front, right? And ultimately return a new string of this answer, right? We just run this code. We will see how this code is working for us. Okay. So yes, it works good. Let me just submit it. You can understand how it is working. Yes. So as you see, this is like 1 MS solution. This 1 MS solution you can see is 100% faster. Obviously, previously I just tried with a 5 MS solution that's using the stack, like the stack from the collection framework. But as I changed it from to the character array, it saved our time because in this case we don't need the stack. So you simply without using this character array, you could have used the exact stack from our collections. The rest of the operations will be the pretty similar. Okay. So that's how it is. Okay. I hope you can understand like how you can solve this question. This is not a very hard question. There can be multiple other approaches to this question also, like using a recursive approach where you just call this make good function from like removing those two characters and taking a substring of two other rest of the elements. So you can just simply call that in that format. Fine. So that can be possible. But I'd say without using this recursion or without using those stuff, keep the stack kind of concept in mind. Why? Because during an interview, I feel like they kind of focus on the collection framework to look how much graphs you have on the collection framework. So that might be they want to ask like, can you show something based on a collections framework? They may ask you. You don't know. Like those are also good approaches, but if they ask you, then it's a better way. Okay, so obviously they won't ask you, can you show me one based on a recursion? Okay, they are not going to do that because everyone knows recursion can end up in something bad situations, right? So it's always good to have a practice of using this collection frameworks and all. So without using the collection framework, that's a way you can do that. Okay, directly not incorporating the framework. So that's how it is, guys. So I hope I can make you understand how you can solve this question. Also, make sure to like this video and subscribe to the channel for regular LeetCode videos like this. Hope to see you soon in my next video as well. Thank you.